Welcome to Module 4, Fundamentals of Data.
So our objectives this week, first of all, we're going to talk about the difference between qualitative data and quantitative data. Second, we're going to talk about the difference between dimensions and measures in Tableau. And third, we're going to talk about the difference between discrete and continuous data in Tableau. The first couple objectives you might not find too difficult. In fact, you may understand it already. But the third one is what trips most people up when it comes to Tableau. So let's go ahead and talk about the difference between qualitative data and quantitative data. And let's just look at quantitative data first. Quantitative data is anything you can measure or count. That's simple enough. Amount of sales, number of orders, profit, anything like that's going to be quantitative data. So quantitative data, they're numbers. You can do math with them. They're measurable or countable, and you know exactly what the difference is between them. So examples of that are weight, cost, anything with a currency number in front of it, discount, or anything with a percentage sign behind it. You may not, you may hear that as percentage or ratio, but generally anything with a percentage sign behind it, that's quantitative data. And then number of orders or number of records, that's quantitative data. Other examples could be profit or temperature. Lots of examples of quantitative data or things that you can measure or count. Now let's jump over to what qualitative data is. Qualitative data is basically going to be used to organize or categorize your quantitative data. And qualitative data can be either ordinal or it can be categorical. Now, ordinal qualitative data has a relationship with each other, but you can't measure the distance between them, but you understand that there is some sort of relationship. So here's some examples. Ordinal qualitative data could be Olympic gold medals, gold, silver, and bronze, excellent health, good health, poor health. Could be a Likert scale, strongly agree, disagree, strongly disagree, or a grading scale, A, B, C, D, F. You know that there are levels to this sort of data, but you can't clearly measure the distance or the relationship between each. Now, there are ways around that, and you may see in a Likert scale, when you're taking a survey, you may see under strongly agree, you may see a number 5, and in agree, you may see a 4, and then the disagree, you may see a 3, and strongly disagree, you may see a 2, or a 2, and then neutral would be 0. That's a way to quantify your qualitative data. Same goes with the grading scale. You'll see, you're familiar with this, instructors will say 90 points and above is an A. 80 points and above is a B. That's a way to quantify those qualitative data. Now, categorical qualitative data, there is no relationship that you can clearly identify, and there doesn't seem to be any sort of order in the data. So examples of this could be the states, could just be a list of names, a list of streaming content. It could be region or market, like in the global superstore data, or anytime you see the word type, that's an indication that's going to be a categorical qualitative data. Now, in regards to visualization, quantitative data, you can measure it and you can count it. Qualitative data, you classify, organize, or provide insight into your quantitative data. So you may hear quantitative data being described as dependent data, or qualitative data is being described as independent data. And the reason in research they say that is because the quantitative data, in order to get some meaning to it, is dependent upon the qualitative data. So that's why they say quantitative data is dependent, qualitative data is independent. Another way to think about that is that qualitative data is going to provide some additional meaning or context to your measures or your quantitative data. So let's switch just a little bit and now start talking about the difference between dimensions and measures in Tableau. This is a general rule of thumb that I will tell you. Dimensions are generally going to be your qualitative data, whereas your measures are going to be your quantitative data. There are exceptions to that though, so just be aware of that. But your measures are going to be numerical quantitative data. When you put them into your view in Tableau, they're automatically going to be aggregated. So when you put profit from the Global Superstore up into your view, it's automatically going to sum it for you. That's aggregation. That's how you know that's a measure. Measures are also going to be dependent upon the dimensions or the qualitative data. So here's an example. So this is shipping cost. If you just throw shipping costs up onto your view, you get a bar. And that's the aggregation of the total shipping costs. And generally speaking, when you put a measure out onto your view just like this, first thing you do, it's usually going to default to sum. Now you can change it to aggregate it different ways. You can use average or median, but generally the default's always going to be sum. Now dimensions, on the other hand, they set the granularity or the level of detail in the view. Level of detail is a term that's used quite frequently in Tableau, more so when you get into more advanced things, and we will talk just briefly towards the end of the class about level of detail expressions. It's a type of calculation in Tableau. It's a little bit more advanced and you probably won't need to use it in this class, but I touch on it just so you're aware of it. But when you hear that phrase level of detail, just think of the granularity of your visualization. Dimensions also are things that you group by or things that you can drill down by or filter by. They are usually, but not always, categorical fields, and they provide insight and context to your measures. So going back to that aggregation of shipping costs in Tableau, so if after I had thrown shipping costs onto the view and I wanted to get a little bit more information about that, I threw order priority onto columns. And this gives me a little bit more information. For example, so order priority, you have 4 levels there. You have critical, high, medium, and low. Now the low, that is kind of what I expected. Low order priority has a much lower sum of shipping costs compared to any of the other order priorities. That makes sense to me. My instinct when doing this would be that critical, that order priority, would have the highest shipping costs affiliated with it, but it doesn't. Medium does. So if I were to go further into this visualization, that's where I would focus. My medium order priority. Why is the shipping cost so much higher with that level than with critical or high? I'd expect it to be much lower. So that's why when you throw a dimension out onto your view, that's why it gives you more insight. It leads you to ask more questions, you dive deeper into the data. So, two things to remember. First of all, that dimensions, when you put them out onto the view, they come out as as themselves. So order priority, when I threw it out onto the view, came out as high, medium, critical, and low. Measures, on the other hand, come out onto the view as aggregates. So shipping costs came out as sum shipping costs. The second thing to remember is that dimensions generally are going to be your qualitative data. Your measures are going to be your quantitative data. So now let's just talk about the most difficult concept, the difference between discrete and continuous data. And this is one of those things that you're going to be happy if you go further into using Tableau that you were introduced to this early on, because it's a kind of a hard concept to wrap your head around, but once you get it, things will make much more sense in Tableau to you. So discrete data means that you have a finite number of isolated values. It's stuff you can count, and it also assumes that there are distinct and separate values. Discrete data can be numbers of pages in a book, shoe size, number of people in a race. Those are discrete things in a greater context. Now, let's talk about continuous data for a second. This will make more sense when we talk about continuous data. Continuous data represents an infinite number of values. You can't count it. It's measurable. And it assumes that between any two values, there is an additional value. So you can always divide up the number further and further and further. So examples of this are the length of the film, the temperature, the time it was taken to run a race, time when you consider the calendar year. You can divide a calendar year into quarters, and then you can divide the quarters into months, and then you can divide the months into days, and then you can divide the days into hours, and you can divide the hours into minutes, and then you can divide the minutes into seconds, and the seconds into milliseconds, and on and on and on and on. You can always drill deeper. That is continuous data. So consider this. Is this always true? Would discrete data mean that it's a dimension, and continuous data means that it's a measure? Not necessarily, and this is what trips people up. There are exceptions, and it gets into that when we talk about time and dates in Tableau. Because dates, although you would think that those are always measurable, they can be used two ways. They can be used discretely or continuously. And things that you can be sure about. Anytime you see text or categories or strings, you can be sure that those are inherently discrete. And generally, those are going to be your dimensions. Now, anytime you see numbers, you cannot be quite sure if they're discrete or continuous. Your numbers are going to be your measures. So your measures can be discrete or continuous, just depending on what type of number it is. So how do you determine when you're working in Tableau what's the difference between a discrete and a continuous data? You'll get to know that more as you use it, but here are some tidbits to help you identify the difference. Two ways: pill color and headers and axes. So pill color. You have noticed already, probably, if you've been paying close attention, when you bring a field onto the view of Tableau, Tableau will create it's a little pill. It's kind of an oblong shape, and that's why they call it a pill, but it's either going to be green or blue. Blue pills are discrete pills. Green pills are continuous pills. So here's an example. number of records, sum of number of records. The pill is green on the column shelf. That means it's a continuous data. Market, on the other hand, on rows is a blue pill. That means it's discrete. Now, the second way you can identify the difference between discrete and continuous data is when you bring them out onto the view, what do they create? Do they create a header or an axis? If it's a measure, it's going to create an axis. If it's a header, it's going to create, if it's a discrete variable, it's going to create a header. If it's a continuous variable, it's going to create an axis. And before I confuse any more, here's an example. So your x-axis, even though we call it an x-axis, this is not an axis technically. It's a header because there's no measures there. That is purely discrete data. Those are years. Your y-axis, that is truly an axis because that is those are measures, those are quantitative data there, and it's a green pill also associated with it, so it's continuous data. So this is something that people sometimes when they're using Tableau at first get confused about, with the difference between headers and axes. This is an example of a Tableau view with two headers. There are no axes here. And if I were to just start off making this view and I put market onto rows and order date onto columns without any measure, what's going to show up is what you're seeing here without the blue boxes. Instead of those blue boxes, you're going to see ABC, 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 ABC in each one of those little cells. And what Tableau is telling you there is, hey, you've given me two discrete variables here, but you haven't given me anything that's measurable, or you haven't given me anything that's continuous data. So I don't know what to do here. So then what you have to do is you have to throw a measure out into the middle of that little table there before something shows up. And your default may be either it will come up as a table, so you'll see numbers, or it'll pop up like this. Well, you'll see a heat map, and you'll see the sum of the shipping costs represented by colors in a range of colors from light to dark. So that is one thing when people start throwing things onto the view without thinking really clearly about what the data represents, they get confused. Like, why didn't I get a bar chart here? You didn't get a bar chart because you didn't throw a measure out onto the view to start off with. And this final example is an example of two axes. So this is a scatter plot. You can see very clearly that you do have two measures. You have discount and you have profit. Discount is on the x-axis and profit is on the y-axis. So that's very clear that you have two measures, that and also that you have two green pills. So you have two continuous pieces of data there. So that's it. That's all I have with the lecture today. Next, what we're going to be doing, we're not going to get much talking anymore about the difference between the discrete and continuous data, and then qualitative, quantitative. I just expect you to do your reading and kind of think about this as you're going along in your Tableau journey. But what we are going to practice this week is using Tableau Prep. And the reason this is new in this course, the reason I'm doing this is because this is a new product with Tableau. If you're going to use Tableau in the future, you're probably going to be asked to try to use Tableau Prep. And Tableau Prep is that piece of software that comes in addition to Tableau Desktop you're going to use to prep and manage and get your data clean so Tableau Desktop can use it more easily. So it's important that you get to know how to use it a little bit. So even if, say, you get into a big corporation, you don't use Tableau Prep, but you use, say, Alteryx, this will give you an idea of what Alteryx will do on a even much higher level. So that's what's going to be the focus of our practice exercise and your graded exercise this week, is actually using Tableau Prep. So that's it for the lecture. I will talk to you again in a few minutes, and we'll get started on using Tableau Prep. Thanks.